Hello, we're working with the Omega Rate Meter Totalizer, model number DPF701. And I'm going to go through a few configuration examples on how to set up the meter in the rate meter mode and in the totalizer mode. In this next step, we're going to set up the meter, or configure the meter, so that we're working with a flow sensor that has a K factor of 93. So that means that we have to divide the signal by a certain factor. And 93 pulses per second would mean a liter per second. So that would be 60 liters per minute. So what we have to do is take that 93 and divide it by 60 so that we get the factor if we were getting a certain amount per minute. And that factor will be 1.55. So to change the factor or the scaling, what we need to do is click on Menu and a second time, so we get to Scale, and then you click on Set. And this indicates that we're taking the input signal and dividing it by a certain amount. And that amount that we're going to divide by is 1.55. So we click Advance, and I already have that 1.55 in there, but if you need to make a change, the way you will do it is to just move the set button and change the value. If you want to get back to 0, just click it until you reach 0. And then to advance it to the next digit, just press Advance. So if I wanted to make this 2.55, I would hit that button, but I'm going to leave it at 1.55. There we go. And if I want to change the decimal point position, which I can, you would actually just click it again, and now you can move the decimal point to where you would like. But I'm going to leave it at 1.55. Once you've done that, then you hit the menu button until you get to this screen, hit the set button, and then the menu button again, and that will store the information into the non-volatile memory. In this example, I have an input frequency of 93 Hertz, which means 93 pulses per second. So at 93 per second, that would be a flow rate of 60 liters per minute, because 1 liter is 93 pulses every second. So 60 liters per minute. So if I change it to say half of that would be about 47 approximately. I'm typing 47 on my generator, and that's giving me about 30 liters per minute. So if I change this, let's change it down to, let's say 30 Hertz. Okay, 30 Hertz would indicate 19.35 liters per minute. And we'll do the calculations on screen to prove that. Now, if I type in 1.55, so I'm getting 1.55 every second, that is giving me 1 liter per minute, which makes sense. Okay, so I'm going to actually increase the frequency. So we're at a frequency there of 26.55 Hertz. And I'm going to go even higher, and so on. So based on that number, I can figure out the flow rate and the frequency. To totalizer mode, so hit Menu. And we have to change the scaling. Since our flow sensor generates 93 pulses per liter, we want to divide by 93 to indicate 1 liter on the screen. So I move to the scale menu, hit input divided by a certain scale, move to the next position, and this is where we want to change it to 93. So I'm going to move to this digit, bump it up to 99 for this one, and 3 for this one, and put these back to 0. And actually hitting the button the first time gives you 0. So now we have everything the way I want, and we're going to go till we get to that no store, hit enter and menu. Now the only thing that we have to do here is to change it so that we're set up for totalize mode. So you hit the menu button again, and set button till we get to total, and then you hit the menu button. If you want to save it, click here. Okay, And now we can go back to the displaying of the information. And this is totalizer mode. So I'm going to type in 93. So that's 93 pulses per second. And I've just done that. And I'm going to reset this. So what I should be getting here is that we have 93 pulses per second. So that would be 1 liter every second. This is making sense. It looks like it's counting up by 1 per second. And if we go down in frequency to say 20 hertz, this is 20 hertz, and you can see that the amount of liters per second has changed. It's much smaller. I'm going to go down to a really low frequency, say 5 hertz. Okay. Now the difference between the rate meter and the totalizer is that in totalizer mode it will always be increasing, and in rate mode it will be at 0 sometimes, go to a high value, a lower value, but it will constantly be changing, increasing or decreasing, or actually even equal to 0 at some time. So this is an example, and I'm testing it with a function generator. Hopefully you'll be able to try this out on your own and get it to work as expected. Thank you. All right, again, we are working with the DPF701 rate meter totalizer by Omega, and this is the back of the device. So anytime you have the back open, make sure that the power is turned off. That's critical, because at this point here we have 120 volts AC, and we don't want you to get a shock from that. Now, the inputs and outputs are on this connector here. This is terminal block 2, and the first one on the left is called the excitation output. So make sure that you're only measuring that voltage, because that's an output signal. You don't want to connect an output to this output. Okay, and this output is either going to be outputting 5 volts, 8.2 volts, or 12.4 volts. So this is something that you measure or use for the devices that you may connect to. This second wire, the yellow one, is the signal input. That's where we're going to be feeding our TTL signal, or a signal from a push button or a reed switch. The third wire that we'll be using is called the signal ground or signal return. It's labeled on the box as RTN. The next one over would be for reset, and this is for a battery input if we wanted to connect a battery, and this is a gate input that we won't be using. Now coming over on the right hand side, these are the different switches. These are the switches you'd set up to operate in 5-volt mode, TTL mode, NPN open collector, or PNP. So a lot of different settings, and we'll refer to a specific sheet in the manual to know how to set these switches. The only thing that's, I suppose, important to note is when the switches are in the down position, they're closed, and when the switches are in the up position, they're open. So the only 2 switches that are closed right now are number 1 and number 4. And that's the default mode for 5 volts at TTL levels.